Welcome to the Unit 11, Section 6 video on real-world applications of quadratic functions. Over the course of this unit, you have learned several methods for solving quadratic equations. Sometimes one method is better for solving certain types of equations. Let's take a look at some of the advantages and disadvantages of different methods. So the first method is by graphing. The advantage is that it always works to give approximate solutions, and we can quickly see the number of solutions. However, the disadvantage is you cannot always get an exact solution. For factoring, it's a good method to try first because it's straightforward if the equation is factorable. But the disadvantages are that it's complicated if the equation is not easily factorable, and not all quadratic equations are factorable. Using the square roots is good because it's quick when the equation has no x term. However, you cannot easily use it when there is an x term. Completing the square always works, but sometimes involves difficult calculations. The quadratic formula always works as well and can always find exact solutions when you can express it in terms of your square roots. However, other methods may be easier or less time-consuming, especially if you can easily factor it. So I like to refer to the quadratic formula as your fail-safe. If you know the quadratic formula, you can always use that by getting it into standard form set equal to 0 and then plugging in your a, b, and c. It doesn't matter what quadratic formula or what quadratic equation you're going to be faced with, the quadratic formula will work every time. However, it's not always the most efficient way to solve. There may be faster ways to solve, and especially if you're on a timed test, you may want to be able to do something that's faster, such as factoring or using square roots. Using the methods we have explored so far in this unit, we can choose the method that works best to solve real-world problems. Let's look at two solutions for a problem here. You've got t equals 2 plus the square root of 20 over 2. You also have this expressed as t is approximately 3.24. Now, what is the advantage of one over the other? Well, the left one is an exact solution, whereas the right one is only an approximate solution. However, both solutions are approximately the same, but the approximate decimal solution is easier to understand. In real-world problems, approximate answers are more meaningful as final answers. Remember to think about the context of your answer. You cannot have negative values for measurements such as time and length. And when we look at these two examples here, knowing that your time is, say, 3.24 seconds, that's something that you can understand. Saying that your time is 2 plus the square root of 20 all over 2 seconds, you don't really have an idea of what that means. So sometimes an approximate solution is going to tell you more than the exact solution. So let's take a look at an example. A ball is thrown upward. Its height, h in feet, is given by the function h of t equals negative 16t squared plus 64t plus 34, where t is the length of time in seconds that the ball has been in the air. When does the ball reach a height of 96 feet? We can set up this equation by setting that quadratic equation equal to 96. Now let's try to solve and find when the ball will be at 96 feet. So we can first subtract 96 from each side. Then we can see what we can do from here. Well, the quadratic formula is probably a good way to go considering the size of our coefficients. Factoring is going to be difficult. So let's go ahead and use our a, b, and c in the quadratic formula. And we get negative 64 plus or minus the square root of 128 all over negative 32. Now you notice I did not simplify that square root of 128. That's because it's not necessary to, because we're going to get approximate answers by putting this into your calculator and getting a decimal answer in return. And when you do that, you get t equals 1.6 seconds and t equals 2.4 seconds. And those are our two times that the ball is at 96 feet. And it makes sense that we have that at 2 times because you have it at 96 feet as it's going up at 1.6 seconds, and then again it's at 96 feet as it's coming back down at 2.4 seconds.
Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.